Composition of functions. So one more operation that you can do with functions is you can do what's called composing them. So composing two functions, what that is it's applying one function's result to another one. So it's like we're evaluating one function and then plugging that number into another one. So what we have here is, let's review what function notation actually looks like. So the first thing we have in function notation is we have the letter in the front. That is just the name of the function. It can be f, g, h, j, doesn't matter. That just tells you which function you're talking about. Then we have this variable or number sometimes inside the parentheses. This is what is being used as the input. This can change. Most of the time it's just an x because we want it as a placeholder in case we have a value later. And then it's equal to an expression which is usually used as the output of your function. So let's review how function notation works. So for example 1, you're given f of x equals 2x squared plus 5, find f of 4. So this means that you are replacing x with 4, and then you're going to simplify down. So f of 4 is equal to 2 times, well now there's my x, so I'm going to put a 4 there instead, squared, plus 5. So 4 squared makes 16. 2 times 16 makes 32. 32 plus 5 makes 37. So that is the evaluated result when you evaluate f at 4. Now let's try one that looks like this. So g of x equals 2x plus 5 divided by x minus 4. Find g of a minus 1. Well, again, you're still going to take whatever's inside this new and you're going to replace x with a minus 1. So you're replacing a variable with another variable, and that's okay. So g of a minus 1 will be equal to 2 times, well there's an x, so I'm going to put a minus 1 in its place, plus 5 over, there's another x, so I'm going to put a minus 1 in its place. Notice it's in parentheses because there's more than one thing that I'm substituting. And then minus 4. So we're going to simplify this as best as we can. So we're going to distribute the 2 on the top. So 2a minus 2 plus 5. Now on the bottom, there's really a 1 on the front here. So 1 times a is just an a. 1 times negative 1 is negative 1. Minus 4. And then I can combine like terms on the top to make 3. Combine like terms on the bottom to make a 5. So my new function is this. So sometimes you may get a number when you evaluate. Sometimes you may get another function, and that's okay. Both of these are exactly the same. So here's what composition of function looks like. It kind of looks like the multiplication symbol, but it's a hollow dot and not a solid dot. So the way we read this is we read this as f composed with g of x. Now the more common way to write this is actually this right-hand side. So this is f of g of x. That's how you read this. So I'm going to write a little note here that this open circle here means compose. This is composition of f and g. Okay, and then the way we read this is f of g of x. That's how we read that in English. So some basic steps. First of all, rewrite the composition the way it's shown. So since in this case, f comes before the composition symbol, that's the outside function. G is after the composition symbol, so that's the inside function. The order does matter, so make sure you are following the correct order that it has. Then we're going to replace each x found in the outside function with the inside. So kind of like replacing x with a 4, except now we're replacing with another function. And then step 3, simplify the result. So let's do an example. Number 1, given f of x equals negative 4x plus 9 and g of x equals 2x minus 7, find f of g of x. So rewrite this f of g of x into a way that makes more sense. So f comes first, so that's the outside, of g of x. Every time you say the word of, write an open parenthesis. So here's what this means. We're going to take, since g is on the inside, we're going to replace all x's in f with g. That's how this works. So here's what we've got. F of g of x equals, so the outside function is f. So since f is this negative 4x plus 9, I'm going to write it without the x. So f is negative 4, and then where x should be, I'm just going to leave an open set of parentheses, plus 9. So that's the outside function. Then we're going to replace where x was with whatever g of x is equal to. So we're going to put 2x minus 7 inside that set of parentheses. So these two things should kind of mirror each other. F is on the outside, so f is the outside stuff, and g is everything that's inside the parentheses where x used to be. Now that we have the composition set up, we're going to simplify as best as we can. So we're going to distribute this negative 4. So we get negative 8x plus 28 plus 9. Combine like terms. Negative 8x plus 37. So this is that new function. F of g of x is equal to negative 8x plus 37. Now, number 2, if you notice, f and g are the exact same functions. F of x equals negative 4x plus 9, again. G of x equals 2x minus 7. But now the order has changed. Now I want g of f of x. So I'm going to have g on the outside of f of x. So the process is the same, but now we're going to take, this is the new input. So replace all x's in g with f. So now we're going the other direction. So g of f of x is equal to, so g now is the outside function. So this 2x minus 7, 2x, but I'm going to just put an open set of parentheses, minus 7. So that's the outside function. And now we're using negative 4x plus 9. We're using f as the inside function. So that's what x gets replaced with. Now again, simplify as far as we can. So we're going to distribute 2. So we get negative 8x plus 18 minus 7, which is negative 8x plus 11. So even though we used the exact same functions, the order made a difference. When you had f as the outside, we had negative 8x plus 37. When I used g as the outside, we had negative 8x plus 11. So the order does matter. It might come out to be the same function, it may not. So make sure the order of the outside and inside you have correct. Example 3. If f of x equals the square root of 2x minus 5 and g of x equals 5x squared minus 3, find f composed with g of x. So we're going to rewrite this guy into something that makes more sense. F is the first, so he's going to be on the outside, of g on the inside of x. So again, we're going to be, g is the inside, so we're replacing all of the fx's with g. So this is equal to the square root of 2, and then here's an x, minus 5. Since f is the outside function, he's the one that's being replaced with other things. Then g is the inside function. That's what x is being replaced with, 5x squared minus 3. Now we're going to simplify this as best as we can, so that means distribute the 2. So 2 times 5x squared makes 10x squared. 2 times negative 3 makes negative 6. And we have minus 5. Combine like terms. Square root of 10x squared minus 11. And that's as far as simplified as we can get, so that is our result for our composed function, f of g of x. Example 4. Given that f of x equals the cube root of x minus 4 and g of x equals x to the third plus 4, Find g of f of x. So let's rewrite this composition into something that makes more sense. G of f of x, so I can clearly see what's the outside function and what's the inside function. So g is the outside, so that's what we're starting with. So we're going to have x, which is going to be something other than x to the third, plus 4. Then our inside function is f, and that's what goes in where x used to be. Cube root of x minus 4. And then we simplify. So if we notice, this root's index and the exponent are the same, so that means those are inverses, so they undo each other. So all that's left is x minus 4, and then plus 4 on the outside. Negative 4 plus 4 makes 0. So the composition of g of f of x is just equal to x. Now, what if there's numbers? So number 5, given that x squared minus 4x plus 2 and g of x equals 3x minus 7, find f of g of 3. So now I don't have an x anymore. So let's rewrite this to something that makes more sense. F is on the outside because he's first, of g is second, and then the input is now a 3. It's not an x anymore. So instead of trying to do this with just the functions, what if I just figure out what this inside part is first? So that's the first thing I want to do. Figure out what g of 3 is, and then we can work from there. So g of 3 means you're going to replace a 3 where x is in the function g. So g is 3x minus 7, so I want 3 times x is now a 3 minus 7. 3 times 3 makes 9, and 9 minus 7 makes 2. So now what we have is we have f of 2. If we take this g of 3, well, g of 3 was equal to 2, so I can freely replace these two things. So g of 3 gets replaced with a 2, and now this is much simpler to handle. I can do f of 2 very quickly, because I'm going to replace all the x's with a 2 inside the function f. So f was x squared minus 4x plus 2. So I'm going to take x and square it. So I'm going to take 2 and square it, minus 4 times x, which is a 2, plus 2. 2 squared makes 4. Negative 4 times 2 makes negative 8, plus 2, which equals out to 4 minus 8 plus 2 makes negative 2. So what we did was we took this actually in pieces. So the equation in the beginning asked us for f of g of 3. Well, we found out that that all equaled out to a negative 2. Example 6. G of x equals the square root of x minus 4, and h of x equals 3x minus 5. Find h of g of 8, sorry. So let's rewrite this guy. H of g of 8. So again, I have an actual number here, so I can take g of 8 and find that first. G of 8 means I'm going to take the g and replace all the x's with an 8. So g of x is square root of x minus 4, so I'm going to have the square root of 8 minus 4. Well, 8 minus 4 makes 4, and the square root of 4 is equal to a 2. So g of 8 is equal to 2. So what our composition has now turned into is h of 2, which that can be the second thing I can find. So h of 2 means in the h function, replace all the x's with 2. And h is 3x minus 5. So 3 times x is now a 2 minus 5. 3 times 2 makes 6, and 6 minus 5 makes 1. So the overall composition, h of g of 8, is equal to a 1.